Okay, y'all, today we're going to be looking at the Pythagorean theorem again, but this time it's going to be in 3 dimensions. It's going to be a relatively hard little topic to cover. I'm going to go over 2 problems, and then for your homework, I'm only going to give you 2 problems because it's kind of hard. So hopefully following along this video will help you out, and I'm going to try to explain it the best way that I can. It's more of a visualization thing. So just try to follow along and try to take notes and pause it if you need to, go back if you need to, whatever you need to try to figure this out. Okay, so on your homework, this one's labeled number 1. Now I'm going to try to draw a picture the best that I can. You have a rectangular cube, or a square cube is what you have. Square cube meaning that all side lengths are the exact same no matter what. Okay, so I'm going to draw this the absolute best that I can. Okay. So there's the cube. Okay. Now on the back side of the cube, you also have, as if we can see right through it. Okay. So that's a 3-dimensional cube. Okay. And this 3-dimensional cube has a length of 4 centimeters all the way around. So every side length you see is 4 centimeters. Okay. And they gave us a whole bunch of labels for each corner. So each corner has its own little label, okay, its own little letter, okay, to help us follow along about what's really going on. He said this was A, this is B, this is C, this one back here is D, up here we have E, and then we have F, and then we have G, and then we have H. And this problem says find the length between AG. Find the length between AG. So we need to find the length between AG. So in order to find the length between AG, we have to first find the length between AC. Okay, because we're trying to find A to G, A to G, G all the way up here, A all the way down here. Now you got to think about it. This actually goes through the middle of this entire cube from A to G. First, we need to find A to C because we need that bottom length. So think as if you're looking at this cube from the side, but you're actually looking all the way through it. So all of the measurements we need all of these colorful ones. We need the green one, the pink one, and the red one. We need all 3 of those side lengths. Okay, currently we do not have the pink one and we do not have the green one, but we do have the red one. The red one is 4 centimeters because remember, every single side length is 4 centimeters. Now we're going to use the Pythagorean theorem for this, okay, because we need to find the pink length first. So find the pink length which is AC, so find AC, find the distance of AC first, okay. So in order to do that, you're going to use the Pythagorean theorem, which is A squared plus B squared equals C squared, okay. Where A, the distance for A, we're going to say that that is equal to the distance of AB, the length AB right there. So from point A to point B, we're going to label that A. And we know what that distance is. That's 4. Okay. Now what about the distance for B? Well, B is the distance between B and C. So the dot B to the dot C is also 4 centimeters. Because remember, this is a cube, so all side lengths, no matter where they're at, are 4 centimeters. Now we do not know what C is, and we're going to call C the pink length. Pink length, which is A to C, we do not know what that is, and that's what we need to figure out. Okay, that's the first step. Okay, so use the Pythagorean theorem, A squared plus B squared equals C squared. We know what A is 4, B is 4, we do not know what C is. Remember, that's the pink length. 4 squared is not 4 times 2, so do not put 8. 4 squared is 4 times 4, which we all know is 16. Add that together, you get 32. Now you have to solve for c. We have c squared. How do I solve for c? How do I get rid of that square? Take the square root of both sides. So I get c is equal to the square root of 32. Now leave it like that, okay? Leave it like that. Leave it as the square root of 32. I'm okay with that, okay? I'm okay with that. Okay, now we get to do the second part. That was part 1. Now part 2 down here. Okay, this is where we actually find the length of AG. Okay, AG. Because now we have all the lengths we need. We have the red length. We just found the pink length. Now we need to find the green length. Okay, so follow me. Still using a squared plus b squared equals c squared. What do we know? We know that, let's call it, oh, maybe I just put a little squiggly line here so we don't get that confused. We have a, which we're going to call it the pink length. The pink length is a to c, so a to c, which we know as the square root of 32 because we just solved for that. That's what we just solved for from the previous little part 1 up there. B, which is given to us, which is the distance from C to G, is equal to 4. And C, which is the distance we're trying to find, which was asked at the very beginning, is the green length. And the green length is from A to G. And we do not know what that is, and that's what we're going to solve for. So A is the square root of 32 squared plus B, what is B? B is 4 squared. And what is C? C, we do not know. So we're trying to solve for. Now remember, a square and a square root, they cancel each other out. Check that out, see? The square and the square root cancel each other out. That's why we left it as a square root of 32. So that's just gives us 32 right there. Okay, the square root and the square cancel each other out. Plus, what's 4 squared? 4 squared, 16, equals c squared. 32 plus 16 gives you what? 48 equals c squared. Now I have solved for c squared. I need c. So what do I do to undo the square? I have to take the square root of both sides, and I get c is equal to square root of 48. So I know that the distance for AG is equal to the square root of 48. And there you go. You're all done with that problem. Now, I know that's hard. Go back through it. Watch it again if you need to. Slow it down. Rewatch a part. Anything you need to. Okay, I'm going to do one more. Okay, one more. Okay. I'm going to do number 3 on your homework assignment. Okay, this is the more difficult one. It's kind of looks weird on the homework assignment. That's why I'm doing it for you on this video. So this one we have it says in the problem you have a rectangular field, but they kind of draw it really weird. So I'm going to just make sure it's a rectangular field so we don't throw each other off. Okay. So here's a rectangle. Rectangle meaning that all corners are 90-degree angles. Okay. And they said that this is A, this is B, this is C, this is D. Okay. They said that this length right here is 9 meters, and this length here is 10 meters. And they also said that there is a tree. Now, I'm going to do my best representation of a tree, but we all know how I can draw, so got a little bitty tree up here. Okay, and they say that the tree is approximately 4 meters tall. Okay, and it's over here at point C, but the top of the tree, they labeled it point E. Okay? So just try to visualize that in your mind. You got a flat surface and you have a tree over there in a corner and it stands at 4 meters high. Okay? So a tree at the edge of a field. All right, now the problem says find the distance between A, E. So you gotta find the distance for AE, okay, which is from the top of the tree all the way down here to A. Okay, top of the tree to A. Okay, so first we need to find the distance from A to C. Because if you think about it, that's the distance that's on a two-dimensional surface. That's on the ground. So we need to find A to C before we find E to A. Okay, and then we also need to use this length right here, how tall the tree is. You see how that makes a triangle? Think of it as if like we're looking at it from the top, but really we need to be looking at it from the side. But we have the tree length, which is 4. We need to find the pink length and then the green length. Okay, so how can we find the pink length? Well, we have a triangle here, C to D and A to D, right? Which could be used to find the pink length. Because remember, it's on the ground, it's on the field. Okay, and if the top up there is 10 meters, then the bottom down here is 10 meters. If C to D on the right side is 9 meters, then this side over here is also 9 meters. Okay, so first, find length AC. Okay, so using the Pythagorean theorem, a squared plus b squared equals c squared, what do we know? We know that A, which we're going to go ahead and say that's from A to D, from A to D, that length right there, what is that? It's 10. And B is equal to what? C to D, that length right there, C to D, which is what? That length is 9. Now we need to find C. C is what length? It's the pink one. So from A to C, that's what we need to find. We do not know what that is. We need that information. Okay, so plug this information into the Pythagorean theorem and solve for C. So we have 10 squared plus 9 squared equals C squared. 10 squared is 100. 9 squared is 81. C squared falls down. 100 plus 81, well, that's not too bad. It's pretty easy. Most of you should be able to do that in your head. 181. Now, how do I undo a square? Square root, both sides. So I get C is equal to the square root of 181. Okay, that's the pink length. That's the pink one. We just solved for the pink one. We need that. So we know that the pink one is the square root of 181. Okay, and we know that the red length over here, how tall the tree is, the red one is 4 meters. So now we have A and B. Now we need to find the green length, which we could call that C. So here's the second part. Okay, the second part. I might have to slide down a little bit, but I'll try to keep it in your visual as much as possible. So part 2 here. Squiggly. Okay, so we have using the Pythagorean theorem, so using a squared plus b squared equals c squared. What do we know? We know that the pink length, which we just found, A to C, call that A, is what? How long is that? Square root of 181. That's how long it is. Now what about B? Remember, we're trying to find the colorful triangle here. We're using all those lengths. B is equal to what? C to E, which is what? How tall is a tree? From C to E, the red length, C to E, how tall is that? It's 4. And then we need to find C. C, which is the green one, the green dotted line that I drew, is from A to E, which is what we need to find. We do not know what that is. That's the ultimate question. That's what we're trying to find here. Okay? So let's use this information to solve for that. We got A, square root of 181 squared, plus B, just 4. We do not know what C is. So remember, a square root and a square, what do? A square root and a square, they cancel each other out. So all I'm left with is 181 right here, plus my 4 squared. What is 4 squared? 16 equals C squared. Now add 181 plus 16 together, and you get 197. C squared falls down. Now the last step, and we're done. How do I undo a square? I take the square root. And I get C is equal to the square root of 197. So the distance from A to E is square root of 197. And you can leave your answer like that. I'm okay with that. Okay. If you guys have any questions, feel free to leave a comment down below on Google Classroom or on this video. It doesn't really matter. Okay, this will be your last assignment of the school year. So make sure that you get everything completed between now and the next couple of days. Okay, because grades are due, I believe, on the 19th. Grades are due on the 19th. So make sure that you get all of your assignments done. Hope you all staying safe.